Hi everyone. So in today's sessions, we will discuss on some of the steps and strategy that we can use to tackle and score for paper 3. Paper 3 is actually a very simple paper, but still a lot of students are not able to score very well for this particular paper. Yeah, so basically there are two main reasons. The first reason is that many school they didn't teach you on how to do paper 3. Yeah, so they expect you will know the whole thing by your own. Number two is your own problem, because just ask yourself, will you take initiative to do some objective question in paper 1 as exercises? Some of you say yes. All right, will you take initiative to do exercises for paper 2? Yes. But will you take initiative to really work on paper 3? Like you go to find your paper 3 question and you try to do it as exercises? The answer is no. All right, many of you only do paper 3 one night before your exam. So that's why you couldn't blame others why you do not score that well when you come to paper 3, because you yourself don't put enough time and effort on paper 3 itself. Okay, now I'm going to brief you on some rough idea for paper 3. Okay, first of all, I need you to know the format. So paper 3, the total mark. So in paper 3, the total marks that we have, it's 50. Yeah, so we have 50 marks in paper 3. So paper 3 can be separated into two sections, which is section A and section B. So section A, we call it a short structure question. So in section A, the total mark would be 33 mark. Meanwhile, for section B, it is planning and design experiment, which is 17 marks. Okay, so for today's session, we will focus on section A, and then I'll film another sessions that talk about section B. Okay, so in section A, we have 33 marks, which actually can be break down into 11 small questions. Okay, so it can be break down to 11 small questions, and every questions will have the full mark of 3 marks. So if you take 11 multiplied by 3, that's how you get 33 marks. So section A can be broken down into 11 small questions. Alright, so I'm going to give you some rough idea and some tips. Okay, so the first thing I want you to know is that the method for you to score paper 3 is differ for all 3 science subjects. Okay, so the method to score paper 3 is differ for all 3 science subjects, which means that the technique for you to solve paper 3 for physics and chemistry and bio might be very different. Okay, so you cannot use a concept that you learn for paper 3 for physics entirely copy the whole thing on chemistry. Not really. They have some small differences there. Okay, and then a very important things I want to highlight today is that please do not ever use a paper 2 mindset or strategy in paper 3. Don't use paper 2 mindset, don't use paper 2 strategy on paper 3. What do I mean? Alright, so guys, when we have a paper 2, when you try to answer a paper 2, just imagine, so this is a paper 2 question. So this is the question, blah, 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 and it's given 3 marks. So in paper 2, whenever you see the question give you 3 marks, what come across your mind? So I believe you know that. Normally, if you have 3 marks, normally you have to write 3 points. So your answer normally you have to write point number 1, point number 2, and point number 3. Okay, so that's normally how we do paper 2. How many marks they gave us? Normally we give how many points. But for paper 3, not necessary. So if they give you 3 marks for paper 3, you don't need to write up to 3 points. Okay, sometimes, which I will show you later, you'll be very surprised. In order to get 3 marks, sometimes you might only need to write one word, not even one sentence. Sometimes you just need to write one word, then you can get 3 marks for your paper 3 already. So at here, I want to emphasize one more time. Paper 2 and paper 3, the marking concept the way how they award you the mark is very different. Okay, I'll talk more about this later. So next on. So when you come to paper 3, which we will focus on section A today. So in paper 3 section A, always follow this particular principle. So this principle, we call it as KISS. So what it means by KISS, guys, KISS stand for keep, okay, it short and simple. Okay, I want you to keep it short and keep it simple. So I don't need you to answer the paper 3 in a very lengthy way. Write a super long answer. No need. Keep your answer short and simple will do. Okay, let me tell you how they give you the marks for paper 3. So we have 4 possible marks that you possible can get in paper 3, which is 3 marks, the full marks, 2 marks, 1 mark, and 0. Okay. So you will get 3 marks if you have a very accurate concept. Okay, if your answer can give a very accurate concept, you will get 3 marks. Although your answer might be very short. Because remember, in paper 3, you don't need to keep your answer super long one. Okay, in paper 2, you will get 2 marks if let's say your concept is less accurate. Okay. So if you have a less accurate, okay, here I write wrongly, okay, so this is accurate. So if you have a less accurate concept, but you still get most of the idea, you get the major idea of it, you will still get 2 marks. So which means that you know something, not everything like you know something, alright, you still get 2 marks. You get 1 mark when you have a weak concept. Okay, you are not totally blank, you still know a little bit, so you will get 1 mark. So you get 0 mark for 2 possibility only. Number 1, you have a totally wrong concept. Your concept totally wrong, or you have no answer at all. Okay, you keep the answer blank, you don't answer at all, then only you get 0. Okay, so guys, although it might sound a little bit sarcastic, but let me be very honest with you. Actually, if you understand and you follow the rules and some of the guidelines which I'm going to teach you later, it is very hard to get 0 mark. It's very hard to get 0. Because as long as you write something and it is related to the question, as long as it is related, you will get minimum 1 mark. Yeah? So please, if possible, don't keep the answer blank. At least you write something, because if you don't write anything, you have no chance at all. Okay, now I would like to give you some rough outline before we discuss in detail. Yeah, so many people complain that there are too many experiments, okay, in chemistry. Not only chemistry lah, including your physics and also your bio. All right. So should you memorize all the experiment, the procedure in every single experiment? So let's answer these 2 questions. So there are many experiments, yes, but you just need to focus on those experiments which is listed in your textbook. Okay? Only focus on those experiments that is listed in textbook. So if you have some extra experiment that appear in your reference book but not in a textbook, you can ignore. Yeah, so you will be only tested on the experiment which come out in your textbook. Okay, next one. Should we memorize all the procedure in every single experiment? No, please don't memorize the procedure. So what you need to do is that I just want you to read through. Just read through the experiment. Just read through and roughly understand what is that experiment all about. We do. You just read through the experiment. You agak-agak know what is this experiment, what is the purpose of this experiment, what you are doing in the experiment. That is good enough. You don't need to memorize every single words or procedure. No need one, okay? So, alright guys. So, what is our objective for today mini course? So, in this mini course, I hope that you can apply all the concept that I covered later, and at the end of the day, I hope that you can improve by a very small margin. Okay, our target is that if you apply all the concept that we highlight today, I hope that you can improve by 5 marks. So don't underestimate the 5 marks. The 5 mark can make quite a lot of difference, because do remember, what is the full mark for your paper 3? Your paper 3, your full mark is 50. So you have 50 mark as the full mark. So if let's say today you apply the concept and you improve by 5 mark, which is very doable. So you improve by 5 marks out of 50. Okay, you multiply by 100%. So that is about 10% of improvement already. Yeah, you just need to apply those concepts. You score extra 10 marks, then you will improve by 10% already. Yeah, so that's how easy it is. Okay, you just follow what I'm going to show you next on. All right, so this is the course outline for today. So today we will discuss on a few things. I'll teach you how to record data. I'll teach you how to write a proper inference. We will learn something on hypothesis. We will talk a bit on observation, which is very easy. We will learn how to play with different variables, and most importantly, we will learn how to do operational definition. This is where a lot of people did terribly when it comes to paper 3. Many people, when they come to paper 3, they are very consistent. Every time when it comes to operational definition, they consistently score 0. They can't even score a mark. Yeah, so I'll show you some of the idea what we can do. Hopefully from 0 mark we can get about minimum 2 marks by apply some small concepts here. Yeah, so this is what we will do. And after I talk about all these things, most importantly, I will discuss with you all on some example. Yeah, we will use some of the example, because many people, they have a concept but they don't know how to apply. So I'll run through a few examples, maybe 2 to 3 examples, to show you step by step how to apply all the concepts that we learned today. Okay, it's very doable. Okay, so now, okay, without further ado, so let's start with the first part. So I will combine some of the concept and some of the exercises so you can see directly what is the concept we learn and how to apply. So the first part that we need to talk today is called record data. Okay, so in SPM, in your science paper 3, they will always ask you to record data, no matter chemistry, physics or bio. When you want to record data, there's only 2 important things, which is there are 2 things which is important. The first one, it's called decimals. Alright, the second one is called unit. So when you want to record the data, you must always know how many decimal points you should use and what is the unit that you should put on. Alright, so sometimes they are very kind, they will give you the unit, sometimes they are not. That's why every time when you do any record, you must always double check. Are they giving you any unit? If the question give you unit, that's fine, you don't need to do anything. But if the question never give you any unit, you have to put on your units. Okay, so now for decimal, so I give you a general rule. Okay, so in chemistry, whenever you want to record data, always go to use 1 decimal point. Always use 1 decimal point for all the measurement, except when you want to measure using this apparatus, which is called burette. I hope everyone know what is burette. Burette is a long tube like this that we learn in your form 4. Normally burette you use for a process called titration. Yeah, so for burette you must go for 2 decimals. Okay, you must go for 2 decimals, 2 decimal points. So apart from that, all the device always use 1 decimal point. Okay, so let me show you some example here. All right. Okay, so this is a compilation of some paper 3 question. So let's try to do together. Okay, I'll discuss a few questions together with you. Okay, let's look at here. So we start with this page. So this is the page 113. All right. So I will put this file in the comment section later, so you can download it if you want. Okay, so for page 113, let's read the question. So diagram 1 shows the apparatus to investigate the electric conductivity of compound in their molten state. So now we want to study the electric conductivity, okay, for molten state. So please remember, guys, what it means by molten. Molten stands for melted. If you take a solid, you heat it up, the solid fully melted, we call it molten. That's what you can see from this picture. Yeah. So we heat the substance, it fully melted. That's why we got molten over here. Yeah. So this experiment, the main purpose is to study about electric conductivity. So table 1 shows the ammeter reading for 3 experiments. So you have 3 things. You have molten naphthalene, you have molten lead 2 bromide, and you have molten glucose. Okay, so these are all the substance that we have. So now let's look at the result and let's try to do this question together. Okay, so now you can see we have total 3 experiments with 3 different molten substances and also their corresponding ammeter reading. Yeah. So the question A asks us to construct a table to record the ammeter reading for 3 molten substances. So now how are we going to do this? So when we want to set up a table, okay, when we want to set up a table, we can do something like this. Okay. So when you want to set a table, a simple thing is that you can copy back exactly the same diagram they give you here, the same table. Okay. So which means that if I want to do it, I can do it like this. Okay, I can do it like this. So the first one I can write down as experiment, okay, which I have experiment 1, experiment 2, and experiment 3. So the second one, as you can see, we have the substances. Okay, so we have substances. If you don't write substances, you also can write this because the question say 3 molten substances. So you also can write here. You can write here as substances or molten substances. Then you put in the 3 things you have. So the first one you have is molten naphthalene. Okay, so we have molten naphthalene. After that, we have a molten lead 2 bromide. And we also have molten glucose. Okay, so there are total 3 molten substance over here. Then in the end, what else they want? Apart from 3 molten substance, they also want ammeter reading. Okay, so you can write ammeter reading here. Okay, so you just write ammeter reading. Okay, one more thing. When you construct the table, please always double check the title of the table. You always need to double check, is the title of the table contain any unit or not. Do you have any units? So for experiment, do you have unit? The answer is no, we have no unit. For substance, do you have unit? No. For ammeter reading, do you have unit? Yes. Ammeter reading is used to measure the electricity. Okay, electricity is measured in ampere. Okay, so over here you can either write a bracket in ampere. If you don't want to write a bracket, you also can use a slash. You slash it and you write ampere here. So far, okay? So then only you put the ammeter reading in here accordingly. So now go back to the table we have. So in this case, what is a proper ammeter reading that we should use? Okay, so let me go on this. So for this ammeter reading, many people will see over here the reading is 0. And then for this one, many people can see is 0.4 and 0.6 in the middle, so it's 0.5. And over here, it's 0. So if you transfer to this, what we call that table, you write over here 0, 0.5 and 0. Okay? So the total full mark is 3 marks. So guess how many marks you can get over here? You are not getting 3 marks, but you only get 2 marks. So why you only get 2 marks? Because of decimals. Alright? So please remember, by default, generally we always let the decimal point in chemistry measurement to be 1 decimal point. So although this is 0, you must write 0.0. You must show 1 decimal point. So I would like to highlight one more time. We always use 1 decimal point except when we use Burette, then we go for 2 decimal point. Okay? So you can see, once you put the decimal point from 2 marks, now you become 3 marks. Just a very small things, you already can make a big difference already. So please remember, yeah, what is the units that you should use? What is the decimal? Okay, the decimal that you should use here. Yeah. So this is the first one. Okay, now I will show you another one more example. Okay, I'll show you another one more example here. So let's go on to page. Okay, so this is page 122. Okay, so this is page 122. Okay. So this is a very famous experiment for your Form 5 Chapter 1. Okay, this is the experiment about rate, the speed of reaction. Yeah. So an experiment was conducted to find out the effect of temperature on the rate of reaction. So you put sodium thiosulfate solution in a conical flask, and then you put a cross sign on the piece of paper. So after that, you add the acid, then you realize that the cross mark will no longer visible, will disappear. Okay, after that, we repeat the experiment for 35, 40 and 50 degrees Celsius. So this is a very famous experiment. If you forget, please revise back your Form 5 Chapter 1. So initially, you take a conical flask, you take a piece of paper, put underneath with a cross. So this is your eyes, so which initially you can see the cross. So initially you put in a solution, which is a sodium thiosulfate. Then after you add in another solution, the acid. When the acid and sodium thiosulfate, they react, after they react, they will start to form some sulfur. So the sulfur is insoluble. When we have more and more sulfur, sulfur become very thick already, so our eyes can no longer see through here. So you will see the cross mark is disappear. Okay, so this is a very famous experiment for your Form 5 Chapter 1. So make sure you know this experiment. Yeah. So for this experiment, what we need to know here. Okay, first of all, as you can see, now they ask us to do the measurement. Okay, they want us to do the measurement here. So this is the stopwatch. So when you have stopwatch, how many decimal point you should have? 1 decimal point. Always use 1 decimal point unless we have Burette, which we use 2 decimal point. So you can go and check this one. You can try to work on it yourself. Okay, so the first one here, if you read it, it should be 55. But don't stop there, 0.0. Okay, so the second one, you can try to read yourself. You'll be 48. Don't stop there, 0.0. The third one, it should be 42.0. Okay, the third one. The fourth one here should be 37.0. And then the fifth one is 33.0. Okay, so that's it. So please remember, you must put the proper decimal. If you only write 55 here, you forget the 0.0, they will cut 1 mark. So please always remember the number of decimal point must be correct. Okay, so here we already, so after you fill in all these data with a proper decimal point, you just earn yourself 3 marks. So this is a very simple one to score. If you don't do careless mistake, you put a proper decimal, you will able to score the 3 marks. Okay, so that's the first one. Okay, now I will go on and talk a little bit more before I go on with inference after this. Okay, next one. So now you are question B. So we're now in question B. Question B, we need to construct a table and to record temperature, time, and 1 over time. So there are 3 things we need to record here: temperature, time, and 1 over time. So let's see how are we going to do this table. Okay, so you have the full freedom to set up your table. How you want to draw a table is all up to you. So let me show you how it works. So I will draw a table like this. I will let the first row to be temperature. Okay, my second row to be time. The third row would be 1 over time. And remember, the title of all these tables, you must check whether you have any units or not. So temperature, what is the unit? Degree Celsius. For time, what is the unit? Second. For 1 over time, what is the unit? 1 over time is second. So you can write second minus 1. Okay? So now, you can try to put in your data. Yeah, you can try to put in your data. So the first temperature that we have is how much? The first temperature we have is 30, 35, 40, 45, and 50. Okay, now some people ask, sir, in this case, all these temperatures, should we also put 1 decimal point? Should we also put 1 decimal point? The answer is no, because you only put 1 decimal point or 2 decimal point when you are going to measure the reading. But in this case, all the temperature reading, you don't need to measure. They already give you. So if they give us the value, they give us the measurement, and then they don't give us the decimal point, then no need. So the decimal point only important, is only significant when you need to measure it. So in this case, they give us, so we don't need. So we have the temperature of 30, 35, 40, 45, and also 50. Yeah, so that's it. So next one, the time. Okay, so this time, you must be careful with the decimal point because this is the time that we recorded just now. So remember, we need to put 1 decimal point. So in this case, we have 55.0, we have 48.0, we have 42.0, and then we have 37.0, and we have 33.0. Okay? So next one, 1 over time. So 1 over time, this part cannot be measured. This is a calculation. So over here, so this is a calculation. So you can try to key in this to your calculator. Yeah, everyone, you can try to key in this to your calculator. So 1 over time. So if you take 1 over time, so 1 over, let's say the time is 55. Okay. So if we take 1 divided by 55, so you will see the answer is 0.0181818 and 18. So this is a long decimal. So when you have a long decimal, then some people will say, how many decimal point we should take? When you have long decimal like this, so how many decimal you should take? Okay, we shouldn't take decimal only. I repeat, whenever you have a long decimal like this, you should take 2 significant figure. 2 significant figure. Okay, significant figure is something you learn in your modern mathematics. 2 significant figure. So in this case, 0.0182 significant figure is up to 18. So now let me do it quickly here. So if we simplify the whole thing here to become 2 significant figure, okay, if we simplify to become 2 significant figure, so this one will get 0.018 then we will get 0.021, we will get 0.024, 0.027, and 0.030. So all these you can calculate yourself, okay? So please be reminded, whenever you are doing measurement, you must make sure when you should use 1 decimal point, when you should use 2 decimal point. When you do calculation and you end up with a super long decimal, you can simplify your decimal in 2 significant figure. 2 significant figure. Yeah? So that is what you need to know. Okay? So hopefully from here you can get some rough idea. Okay? So now I would like to go on a little bit. Okay? So let's go back to here. Okay. So now I already show you how are we going to do the recording. How are we going to record the data? Okay. So the next thing that I will talk about is called inference. Okay. The next thing that I would like to talk about is called inference. Okay. Alright. So for the second part, okay, so we already discussed and talked about record data. So let's talk about inference now. Okay. So when you come to inference, many people heard about inference since UPSR. Alright. Many people, you heard about inference as early as UPSR. But until today, still a lot of people cannot get a very good full marks for inference. So now I'll tell you what is inference and why many people lose mark in the inference. Okay, I'll tell you what is inference all about and why many people lose mark in inference. Okay, so when you come to inference, inference is about a brief. Okay, inference is a brief explanation. Okay, inference is a brief explanation of observation. So which means that when you observe something, you try to explain why you observe that. So that is called inference. I repeat, inference always related with observation. When you observe something and you try to explain why, so it is called inference. Okay, what is a common problem when you come to inference? Okay, when it comes to inference, many people, the common problem is that they over-explain. Okay, the common problem for many students is that they over-explain. Over-explain in the other means that they explain too deep. Too deep explanation. Alright, you shouldn't explain so deep when you come to inference. It should be a very brief explanation. Okay, what do we mean over here? Okay, I'll show you one example. Okay, go back to the question we have just now. So go back to the first question that I discussed early on today. Okay, this is the one. Yeah. So again, help me to recall back. This is the experiment to study about electric conductivity. So we want to know who can conduct electricity, who cannot conduct electricity. Yeah. Okay. Now, if you look at it, okay. Now let's look at the questions. So question B. Based on the ammeter reading, tell me one inference for this experiment. So what is the inference? Okay, so remember, inference is all about observation. So what you can see first. So what we can see, molten naphthalene. So when we use molten naphthalene, ammeter reading is 0. When we use molten glucose, ammeter reading is 0. When we use molten lead bromide, ammeter got reading 0.5. So why? So what is the inference? Okay, so now you have to ask yourself, why the ammeter got reading? Okay, so always remember, ammeter, the main purpose is to measure the electricity. So when there is electricity, the ammeter will show some reading already. So in this case, okay, as you can see, molten naphthalene and molten glucose, they have no ammeter reading. So when no ammeter reading, which means that molten naphthalene and molten glucose, they don't conduct electricity at all. Yeah, because look at here. What is the purpose of this experiment? We want to study the electric conductivity. So we want to know who can conduct, who cannot conduct electricity. So molten naphthalene and molten glucose, the reading is 0, which means that they cannot conduct electricity. Molten lead bromide, the reading is 0.5, which means it can conduct electricity. So how are you going to write the answer? The answer is very simple. Just need to write molten naphthalene. Okay, no, molten naphthalene and also molten glucose, okay, do not conduct electricity. And don't stop here, because many people, they stop here and you will get some mark but not full mark, because you only tell people about molten naphthalene and molten glucose. You cannot expect the examiner will know what happened to your molten lead bromide, so you must tell them. So molten lead to bromide able to conduct electricity. That's it. Okay, so that is how you explain. Okay, so for molten naphthalene and molten glucose, we don't see any reading at all, which means that they will not conduct electricity. For molten lead bromide, we see there is ammeter reading, which means they conduct electricity. Okay, so what is the common mistake for many students over here? Like what I say, many students always over explain. Many students will love to write this. Okay, they will write molten naphthalene and also molten glucose do not contain free moving ion. So molten lead to bromide contain free moving ion. So this is what a lot of students will write. Guess what? If you write this, you don't get the mark at all. Why? Because you explain too deep already. Yeah. So when you come to inference, always remember inference, the explanation must be brief. Okay. Do not over explain. Okay, so just give a very simple and a brief explanation will do. So when only you should use free moving ion, when you should explain so deep, you should only go deep when the question asks like this. You see, so let's go down. Now look at question G. Look at question G. So for question G, based on experiment 1 and 2, based on experiment 1 and 2, explain the difference in ammeter reading. When you see the keyword explain, then only you go detail. So how are you going to write this? So experiment number 1. So how to explain? Experiment number 1, molten naphthalene. Ammeter reading 0. 0 means cannot conduct electricity. Why you cannot conduct electricity? When they ask you explain, then you go deeper. Then only tell people why you cannot conduct electricity. So only write the answer. Molten naphthalene. Okay, molten naphthalene do not contain free moving ions. Yeah. Meanwhile, in experiment number 2, you can see your molten lead bromide can conduct electricity at 0.5. So when you can conduct electricity, it's because molten lead to bromide actually contain something that can carry electric, which is called free moving ions. Okay, So please make sure everyone know when you should explain deeply, when you should touch and explain briefly. Yeah, you explain briefly when the question asks for inference. You only go deep when the question asks you to explain. So please watch out the keywords. That's why I say overall paper 3 is not hard, but you have to be very, very careful on what they want. Else you will lose the mark, and you won't, and many people, they not even understand why they lose the mark. Yeah, so this is very, very important. Okay, so make sure everyone gets some rough idea what do I mean over here. Yeah. So this is something we call inference. So inference, you just give a very brief explanation, very, very brief explanation based on what you see. Yeah, what based on your observation. So that is called inference. Okay, we try to do another one short question before we go on. Okay, so now we try to do another one more experiment. So this is the experiment that is quite famous in your Form 4. So in Form 4, there is one experiment, okay? So this experiment is about a concept that we call alloy. Yeah? We call alloy. So it is on page 138. So this is page 138. So this is the experiment that related with your Form 4 chapter 9. Okay, the concept of alloy. So if you forget, please revise back. So I'll give you some rough idea before we do this. We discuss this question together. Alloy is harder than its pure metal. Always remember, alloy is harder than its pure metal. Okay, so this is what they do for experiment. They put a weight, and then they put a copper block here, and then here they put a steel ball. They drop the weight, so when the weight hit on the copper block, the whole thing will concave like this. Yeah, then after that, they change this copper block to bronze. They change it to become alloy, and then they repeat the same process again. So the weight drop here, hit on the ball, then you will see another concave as well. Yeah, so we want to go and study how big is the size of this gamete thing. So this is called dent. Okay, we want to study the diameter or the size of the dent. Okay, so the idea very simple. If the dent is very big, which means that your material is very soft. If your dent is very, very small, then the material is very hard. Yeah, so this is the experiment to study about hardness. Okay, hardness of the material. Yeah, so now let's look at here. So let's do it quickly. So first of all, so this question asks us to do a recording data. Okay, so we want to record data, so I do it quickly here. So in this case, let's look at it. So what apparatus we have over here? We have ruler. So for ruler, when we want to do measurement, how many decimal point? 1 decimal point. Okay, so you can try to do the measurement. You can try to draw a line here, take a reading here, we call B. You can draw a line here, take a reading A. We take B minus A, then you will know how much is the size of the diameter of the dent. Okay, so I do faster here. So if let's say I do faster, so this one I will get maybe 1.3. So this one I will get 1.6, and I'll get 1.5. So this one I get 1.2, this one I get 1.0, this one I get 1.2. Okay, so make sure you put 1 decimal point. If you don't put 1 decimal point, they will penalize. So if you, after you put all this value, how many marks you can get here? So out of 3 marks, if you do this, will you get 3 marks? No, you won't. You will only get 2 marks. So why you only get 2 marks? So just now I mentioned, when you want to do recording, when you want to record the data, there are 2 important things. One is called decimal, another one is called unit. So in this question, we already get the decimal correct. which is 1 decimal point, because only Burette is 2 decimal point. The rest all are 1 decimal point. But for this question, they don't give us any unit. So the question don't give us any unit at the back. So you have to be careful. Sometimes they give us unit, sometimes they don't. You look at the question just now. So if you look at the question just now, sometimes they are very kind, they give you the unit one. Okay, so let's say the question we have just now for the stopwatch. So you see for this question for the stopwatch, you see the unit is given second. So they give you the unit at the back. But for this question that we are doing now, they are not giving us the unit. So when they're not giving us a unit, we have to put in ourselves. So what is the unit for the ruler here? As you can see on this picture, look at this picture, it is centimeter. Yeah, so we have to put in the unit centimeter. Okay, so this is very important. Okay, so from here we can learn and we know something regarding the measurement. Okay, so next one, so we can construct a table to record the diameter and average diameter. So we want to do a table to record diameter and average diameter on copper and bronze block. So you can be very creative on how you're going to structure or draw your table. So for me, I'll draw the table like this. So I'll draw a table like this. So first of all, so always start your table, the front part here, with your manipulated variable. What are the things you changes? Then only at the back here, you put your responding variable, or we call it as result. So sequence is very important. When we try to draw a table, the front part normally is the manipulated variable. What are those things that you are changing? And at the back part is the responding variable. What is the result that you are getting? So in this case, what we are changing on different types of block. So this is the different block that we have. So I'll write this. Okay, I can write type of block. You can write type of block, or you can write material of block. So we have two possible material. One is called copper and one is called bronze. Yeah. So next one, what we want to measure? We want to measure the diameter of the dent. So we want to measure the diameter of the dent. So for diameter, what is the unit? Centimeter. So how many measurements we are doing, guys? We are doing 1, 2, and 3. We are doing three measurements, and they also ask us to find average. So we need to do 4 things. So first measurement, second measurement, third measurement, and last one is average. Okay, so just put in the value that you know. Okay, you can put in the value you know. So you can copy back from the table on top here. So this is 1.3, this is 1.6, this is 1.5, this is 1.2, this is 1.0, and then this is 1.2. So average, you can calculate it. You just add all these 3 together and divide by 3 . So average for copper, you can calculate yourself, you get 1.5. Average for bronze, you can calculate yourself, you get 1.1. Okay, so by constructing this table, you just secure yourself 3 marks. Okay, so that's how the whole thing works. Alright, so now this is a simple recording data. Okay, now next one. State one observation you can obtain from both experiment. Okay, so now I would like to talk a little bit on observation. Okay, so as you can see, we already covered record data and also inference. I will talk a little bit on observation first before we go on and talk about the rest. Okay, so guys, so in chemistry, observation is always related with your 5 senses. Okay, observation is always referred to the 5 senses here. Okay, so the first one, that we have is this. Okay, what we can see. Number 2, observation can also refer to anything that we can smell, anything that we can taste, anything we can hear, as well as anything we can touch or anything we can feel. Yeah, But generally, when you come to chemistry, observation, we focus more on what we can see. So you must tell people clearly what you can see. So when you want to tell people what you can see, one of the tips can help you is that you can tell people whether you see a solid, a liquid, or a gas. You also can tell people color. Is there any color or any color changes? Okay, so that will give you a good idea for observation. Okay, you cannot say, all right, let's say there is an experiment. You know exactly the experiment is produce copper. So you cannot say a copper is seen. You cannot write that, because when you first look at it, you have no idea at all that is a copper. So how you going to write it? So for observation, you should write, okay, so copper appear as solid, liquid, or gas is a solid. Okay, any color that you know about copper. Copper, if you recall back, copper is a brown color solid. So you should write a brown solid is produced or is seen. You don't write copper is seen. Okay, so you cannot write the name, although you know exactly what it is, because when you come to observation, when you first look at it, you don't know what is the identity of the substance. Okay, so please be very careful with the observation here. Okay, so observation is very simple, nothing much here. So now come back to here. So in this question, they ask us, what is the one observation that we can notice from both of these experiments? So in this experiment, what we are looking for, what we can see. So this experiment, like what I said just now, we are trying to drop the weight to hit on the steel ball bearing. The steel ball bearing will produce a small dent, will produce a small hole. So we are focusing to observe on the size of the dent. So although we do the measurement for 3 times, but if you look at the average value, you will notice that the copper, the average size is 1.5, and for bronze, the average size is 1.1, which means to say, no matter you do the measurement for first, second, or third time, generally you will see the bronze produces a smaller size or smaller diameter of dent in comparison to copper. Okay, that's what we can see. So we can write it up. So our answer, I'll write in this way. So for my answer, I'll write diameter, okay, of the dent. You can say diameter of the dent, or you can say size of the dent on the bronze. Okay, block. Okay, the dent is on the bronze block, is actually smaller. Okay, don't write smaller only, you must say smaller than what. Whenever you want to do comparison, you must compare with the right what we call that counterparts. So it's smaller than what? So the diameter of the dent on the bronze is smaller than the diameter of the dent on copper block. Alright, so that's what you need to do. So you must mention that you are observing the diameter of the dent, and the diameter of the dent on the bronze is smaller than the copper. Then some will ask the other way around. Some people say, sir, can we mention the other way around? Can we say that the diameter of the dent on the copper is larger or bigger than the diameter of the dent on the bronze? Yes, no problem. Okay, as long as you can show the comparison will do. Just tell people who is bigger, who is smaller will do. But you must clearly tell people what you are comparing. You're comparing bronze and you're comparing copper, and what you are observing, the diameter of the dent. So it's not very hard, but your answer must be more detailed. You must write a detailed answer in this case. Alright. Next one. Okay, so this one back to something that I'm talking just now. Alright. Based on the average diameter of the dent, state the inference. So now we need to give inference based on the diameter of the dent. So recall back, what is inference? the reason, okay, the reason that support your observation. So when you observe something, so what is the reason that contribute to that observation? That is called inference. And I say just now, for inference, don't go deep. Don't over explain. Keep it simple. Okay, keep it simple for inference. So now, as you can see, the bronze has a smaller dent compared to the copper. So now you need to support with inference. Why? So you have to ask yourself, why? Why the bronze has a smaller dent, smaller diameter of the dent in compared to the copper? So always remember, the size of the dent tell us about the hardness. So for bronze, you have a smaller dent is because bronze is harder than copper. That's it. Yeah, you just need to mention bronze is harder than copper. That's it. So this is a good inference because this actually explains why the bronze has a smaller size of the dent. Bronze is harder. When the bronze is harder, when you hit the weight to the steel ball, so the dent will be smaller. Alright, so this is how are we going to write a good inference. Okay, explain our observation briefly. Don't go too complicated. Yeah, alright, so that's it. So this is for our inference over here. Okay, another one things that I want to talk about is this. Okay, so next on, so I would like to talk a bit on this. How to play with different variable. How to play with different variable. Okay, so let's talk a little bit on variable here. Okay, so we know that there are three common variables. Okay, we know there are three common variable, which is manipulated variable, responding variable, and constant variable. Yeah, so we have manipulated variable, responding variable, and we call constant variable, or some of the book they call it a fixed variable. Okay, so we have total three possibility here. Okay, so I believe most of you are very good with the variable, nothing hard, but there's one questions they love to ask. Okay, there's one question they love to ask that you all have to be very careful. Okay, so the question is all about on how are we going to change the variable. Okay, how to change the variable. Okay, how are we going to change the manipulated variable? How are we going to get the responding variable? How are we going to get the constant variable? So you all have to be very careful here. Okay, so let me show you how they ask the question first, then I'll talk a bit more on this. Alright, so you can see. Okay, now complete the table below for this experiment. So for this experiment, so you can see, so you have manipulated variable, responding variable, and constant variable, and this is the one, action to be taken, means what you need to do. Okay, now how are you going to manipulate the variable? So what you need to observe in the responding variable, and how are you going to maintain the control variable? So many people can score quite a decent mark at here, but not here. Many people did quite badly for the three things on the right hand side. So now I'll show you how am I going to do the question. So let's do a simple one first. I think we can do the left hand side. I think the left hand side shouldn't be too hard. Yeah, so let's do the left hand side first. So on the left hand side, so we must able to identify our variable. So what is the manipulated variable? So in this experiment, what we are manipulating, what we are changing. So in this experiment, we are trying to change the bronze and also the copper. Okay, so bronze and copper. So bronze and copper, so many people will write this. Okay, type of block, which is okay, but when you mention the word type, type is not accurate enough. So how are we going to make it even better? Alright, so bronze and copper is used to build the block. So a better answer, maybe we can consider to put this word, okay, material, okay, material of the block. So that would be a better answer. Yeah. So next one. So for the responding variable, okay, so now for responding variable, so when we change a different material of the block, so what is the result that we want to see? Okay, what is the result that we want to see? So in this case, when we change different materials, so we want to see the size of the dent. Okay, again, if you mention the word size is not accurate enough, so how are we going to measure the size here? So better we can write the word as the diameter. Okay, the diameter, okay, of the dent. Okay, the diameter of the dent. So the control variable, what is the control variable? In this case, what we need to fix. So always remember, guys, control variable must be something that can potentially affect the result. It must be something that can potentially affect the result, and we need to fix it. Okay, that is called control variable. So in this case, what is the result we want? The diameter of the dent. So you ask yourself, apart of different material of the block, apart from different material of the block, any other factor that can also affect the size of the dent? Okay, there's a few. For example, the weight. Okay, the weight, you must fix it. You cannot use the first experiment you use 1 kilogram, you drop it, and the second experiment you use 4 kilogram, you drop it. It's unfair, because if you use different weight, hit on the steel ball bearing, the size of the dent will be very different. Okay, so we need to control the weight. What else you might also can control? The height of the weight that you drop it. So let's say initially you drop at the height of 50 centimeter. So when you repeat the experiment, you must use 50 centimeter as well. Else, if you use different height, when you hit on the steel ball bearing, the dent will be different size as well. Yeah. So in this case, the control variable, maybe we can control the mass of the weight. Yeah. So that's it. So these three parts, normally, if you don't do careless mistake, you should be able to get a quite decent mark. Alright. So, but again, our main focus is on the right hand side. How to change the action to be taken. So when you want to, when we want to do the, when we want to take actions to play along with all these variables, we all have to be very careful. Okay. So let me talk a little bit on this. So how to change the variable here? Okay, how are we going to change the variable? So if you want to change variable, you must always use a proper words. Okay, you must use a proper words. Okay, it will be better if you can do this. It will be better if, let's say, you can use a proper verb. Okay, use a proper verb, and also, if possible, you state the instrument that you use. What kind of instrument, what kind of apparatus you are using to change or to play along with those variables. Okay, what do I mean? So I give you a general tips. Okay, so when you come to manipulated variable, okay, when you come to manipulated variable, okay, you can start the word with this. Okay, use. Okay, use blah 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 blah. Okay, use blah 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 blah. Okay, so that is one of the words we can use. Okay, so I'll show you how to do later. So the second thing, when you come to responding variable, okay, when you come to responding variable, so you can go for the word call. Okay, normally when you come to responding variable, they will ask you what you should do with it. It's better for you to start with these two words. Okay, the first word, better you go to put it as measure. Then the second word, you should go along with record. Because normally when you come to responding variable, we are getting result. When you're getting result, normally you need to do measurement and recording. So try, every time when they ask you how to get the responding variable, try to start the answer with measure and record. Measure what and record what. Okay, so that will be a better one. And if possible, tell people the instrument that you use to do measurement. Okay, so try to put the word measure and record something. Okay, I'll demonstrate how to do it. Last one is called your control variable. So when you come to control variable, something you need to fix it. So when you want to fix it, so it's better for you to use these words. Okay, the first word you can use is this. Okay, you can use the word called fix. Okay, fix blah blah blah. Or the second word you can use is called maintain. Okay, maintain blah blah blah. So these are some of the keywords that you have to be careful. Okay, so I repeat, for manipulated variable, you can put the word use something to change something. When you come to responding variable, it would be better if you can put the word measure and record. And when you come to control variable, it will be better if you can put the word called fix or maintain. Okay, now let's apply on this question. Okay, so for the first one, so for the first question, they ask us how to manipulate the variable. So how to manipulate the variable? So what is the manipulated variable? The material of the block. So how you manipulate it? You can use the answer like this. Okay, you can use it like this. You can say use. Okay, so initially the experiment, what you do, initially the experiment you started with copper block. Then only you need to change the copper block with bronze. So you can write the word use bronze block to replace copper block. Okay, so this is one of the very simple answer. So if possible, start with the word use. Alright, initially you have a copper block. So when you repeat the experiment, you want to change the material, you use the bronze block to replace the old copper block. Yeah. So next one. So what to observe in responding variable? So in this case, they ask you what to observe. Okay. So when you come to observation, okay, so better you go to do these two words. Okay. The first word is called measure. The second word is called record. So better you write the word measure and also record. So what you want to measure and record? Okay, so the responding variable, we are focused on the diameter of the dent. So we measure and record the diameter of the dent. Okay, measure and record the diameter of the dent. And if possible, although this is not a must, for chemistry still okay. So although it's not a must, but it's better if you know what apparatus to use, go ahead. Measure and record the diameter of the dent using ruler. So that they are very clear of what you are doing here. Okay, so if possible, try to tell people, okay, what is the instrument that you use for the measurement purpose. Okay, now come back to here. So the last one, mass of the control variable is the mass of the weight. So now, how are we going to maintain the control variable? So when we want to fix the variable, when we want to control the variable, the better word we can use is this, the word fix or the word maintain. Fix or maintain. So now, we can start the word with fix. Okay, let's say we use the word fix. The weight. Okay, fix the mass. Okay, fix the mass of the weight. And you must tell people clearly what is the mass of the weight. What is the mass of the weight that you need to fix. Okay, so if you look back, I think they will mention here, okay, the question here. So the question do mention that the weight is 1 kilogram. Okay, so please, your answer must go as detailed as possible in this case. Alright, so when we want to come to action to be taken, try to give your answer in a bit more detail one. Fix the mass of the weight at 1 kilogram. Yeah, fix the mass of weight at 1 kilogram. So we will know for all the experiment, we always use the weight at 1 kilogram. Okay, so this is how you maintain the variable. Yeah, so the keyword is very important over here. Okay, so make sure everyone know these kind of keywords. Okay, but sometimes you write it out but you don't put the keywords, so they don't give you the marks that you deserve lah. Okay, so that is how are we going to do with the variable. Okay, this is how are we going to play along with variable. Okay, so the next thing that we will talk is called hypothesis. Okay, so we will talk a little bit on hypothesis. Okay, so for hypothesis, will always give you 6 marks in paper 3. So you always get 6 marks when you come to paper 3. Why you get 6 marks in paper 3? Because they will ask you in section A and section B. Okay, for section A and section B, they will ask you hypothesis, which you have 3 marks each. So by knowing hypothesis, you can secure 6 marks already. So please make sure you know how to write a good and a proper hypothesis. Okay, so what is hypothesis all about? Hypothesis is the relationship. Hypothesis is all about the relationship between manipulated variable and responding variable. Okay, so hypothesis always talk about the relationship between manipulated and responding variable. And when you come to hypothesis, sequence is important. Okay, when you come to hypothesis, sequence is important. When you write the hypothesis, always make sure the front part you go to put manipulated variable. Then only the back part you talking about responding variable. Okay, the sequence is very important when you come to hypothesis. And when you come to hypothesis, you are talking about the relationship. So when you come to relationship, please do not use some of the neutral relationship. Don't try to use some neutral relationship or neutral words. Okay, what it means by neutral words. Okay, you don't use the words such as affects, okay, such as influence only. Example, you don't write this. Okay, temperature affects rate of reaction. Okay, if you write this as your hypothesis, okay, let's say your temperature is your manipulated variable, your rate of reaction is responding variable. If you write temperature affects rate of reaction, you are not getting full mark. Why? Because you don't tell people detail enough how the temperature affects the rate of reaction. Okay, we only know that temperature and the rate of reaction, there is a relationship, but what is the relationship? How to make it a bit more detailed? Okay, so when you talk about relationship, the relationship must be very detailed. Okay, so try to always give a detailed relationship. So I change a words here. I change it something like this. Okay, so I want a more detailed relationship between manipulated and responding variable. Okay, so that is a good hypothesis. Okay, what do I mean? So how to make this a bit better? Okay, so you can change like this. Okay, when temperature is higher, the rate of reaction is higher. So from here, you can see that the answer now in terms of the relationship is much more clearer. So when you have a clear relationship, then only you can get the full mark, which is the 3 marks. Okay, so when it comes to relationship, try to make sure the relationship is clear, very clear relationship. And not to say hypothesis must follow the format, the more blah blah blah, the more blah blah blah. It's not a must. I mean, if you can write in that way, it will be fantastic, but it's not a must. Sometimes you cannot write in that way. Yeah, sometimes you just cannot write in that way. As long as you can write a good statement for the relationship between manipulated and responding variable, that would be a good hypothesis already. Okay, so now let me show you this. Let me show you two questions based on what we learned just now. Okay, so let's look at here. Okay, all right. Okay, so let's say we go for the questions for rate of reaction that we learned just now, the cross mark, the cross sign. Okay, so now the question is asking us about this. Okay, so let's try to do this. Okay, question E and question F. So question E, tell and state the variable involved in this experiment. So what is the manipulated, responding, and constant variable? So what is the manipulated variable? So in this experiment, what we are doing? In this experiment, what we are changing? We are changing the sodium thiosulfate solution. We heat it to 35, 40, and 50. So which is temperature. So if you only write temperature, it's not good enough because you must specify this temperature is referred to what? Sodium thiosulfate. So the better answer you can write is this. Temperature of sodium thiosulfate solution. Yeah. So next one, for the responding variable. So what is the responding variable? What is the result that we want? Where we change different temperature, so we want to see how fast the X sign disappear. How fast the X sign disappear. Okay, you can say X sign disappear. You also can write this. An experiment was conducted to find out the effect of temperature on rate of reaction. So they change the temperature. They want to see how fast the cross, the X disappear, which is the rate of reaction. So your responding variable, you can write time taken for the cross mark, okay, to disappear. If you don't want to write that, you also can write rate of reaction. Yeah, because our main objective of this experiment is to study the rate of reaction, okay, by changing different temperature, how the rate of reaction responded. Okay, so next one, constant variable. So constant variable must be something that can potentially affect the result that you need to fix it. Okay, so what is the main purpose of this experiment? This experiment, the main purpose is to study the rate of reaction. Okay, we learned in your Form 5 Chapter 1, your rate is affected by 5 factors, which is temperature, which is your concentration, pressure, size of particle, and also catalyst. So just now they changed the temperature. Okay, so we have other 4 factors that can potentially affect the result that we need to fix it. Okay, we don't use the catalyst here because the whole question do not mention about catalyst. We also don't use the size here because size is only applicable whenever we have solid. So in this experiment, There is no solid at all. This experiment, they are mixing two solutions. The first solution they are mixing is actually called sodium thiosulfate solution. The second one is hydrochloric acid. So when we have solution only, there is no solid, so we don't put the word size. Yeah, so size is off lah. So we don't go for pressure as well, because pressure only applicable if we have gas. So we don't have gas here. The sodium thiosulfate and the hydrochloric acid, both of them are liquid, they are solution. So we don't go for pressure. So we left with concentration. So we need to fix the concentration. Okay, so normally when we have a solution, we always fix concentration together with the volume. We always fix concentration and volume together. I repeat, whenever we have a solution, normally we fix the concentration and the volume. So what is the concentration and volume that we need to fix over here? The solution of, we have two solutions, which is sodium thiosulfate. Okay, sodium thiosulfate solution, we need to fix it. And also another solution is hydrochloric acid. So please try to be specific. Tell and mention in your answer when you want to fix the volume and concentration, you are fixing the volume and concentration for who, for which solution. Okay, try to write your answer as detailed as possible in this case when you come to variable. Okay, next one. So the next question is asking us, how are we going to manipulate the one variable? How to manipulate the one variable? How we change the variable while keeping other variable constant? So same thing, we have to use a proper word here. So when we want to manipulate, you can use the word use. Okay, can use. So what is the manipulated variable? Temperature. Okay, use different temperature of sodium thiosulfate solution. If you don't want to put the word use different temperature for sodium thiosulfate, you also can go the other way around. Just imagine you have a sodium thiosulfate, initially is 30. How you want to make it 35, 40. So if you don't want to put the word use, you also can use, and you also can put another word, heat. Okay, heat the sodium thiosulfate solution to different temperature. You also can write in that way, no problem. Yeah, so you must know what is the action to be taken to change the variable. Okay, so for manipulated variable, you can put the word use different temperature. Okay, or you can go more detail, heat the sodium thiosulfate solution to the temperature you want, 30, 35, 40, and so on. Yeah. Alright, so how you keep another variable constant. So how you fix those constant variable. So for constant variable, try to put the word fix or try to put the word maintain. Okay, fix and maintain the concentration and the volume of sodium thiosulfate solution and hydrochloric acid. Okay, so write it down. You fix and maintain the concentration and the volume of sodium thiosulfate and hydrochloric acid. Okay, so yeah, that's it. Okay, so now next one. Now we have to talk about the hypothesis of this experiment. So for hypothesis, you must try to relate your manipulated and responding variable. Okay, and the sequence is very important. Manipulated in front, responding variable at the back. Okay, so our manipulated variable is temperature, and then our responding variable is time taken, or we call rate of reaction. Okay, so the not so good answer is this. If you write, okay, temperature will affect the time taken for the cross mark to disappear. Okay, if you write this answer, you will get some mark, but not full mark, because the relationship is not clear enough. So how to make it more clear? How to make the relationship clearer? Okay, so you can change a little bit like this. Okay, you can change the keyword like this. When temperature increases, the time taken for the cross mark to disappear become shorter. Yeah, so you take a shorter time for the cross mark to disappear when the temperature is increases. By doing this, so you will have a very clear relationship. Okay, so your relationship must be as clear as possible. Yeah, so if you don't want to write the cross mark disappear, you also can change, because look back to here, your responding variable, you can write the time taken for the cross mark to disappear. You also can write rate of reaction. So you also can change the answer like this. When temperature increases, rate of reaction increases. Also can. As long as you have a relationship between manipulator and responding variable, and the sequence is correct, manipulator in front, responding at the back, and the relationship is very detailed and clear, you're going to get your full mark for your hypothesis. Okay? Alright. So now we have covered the hypothesis. Okay, now it comes to the last one, the most important blockbuster, which is operational definition. Okay, operational definition. So this is the part that a lot of people having some problem with operational definition. Okay, so let me show you what is operational definition. Okay, so for operational definition, the first thing that you have to understand is this. Operational definition is not the same as the definition in the book. Okay, it's not the same as the definition that you learn in your textbook. Okay, so they are not the same. Yeah, so example. Okay, if the question asks you what is the operational definition of acid, so if you go to put the entire definition of acid from textbook, you write this: acid is a substance that ionizes in water to produce H plus ion. So this is a definition that you learn in Form 4 Chapter 7. So if you write in this whole answer, you dump this whole answer into the question, you will get 0, no mark at all. Yeah, because the answer that you gave is a textbook definition. Okay, now we don't want a textbook definition, we want operational definition. So what is operational definition? Operational definition comes from the word operation. Operation means you have to do something. Okay, so you have to do something. What it means by do something? When you come to chemistry, the do something means experiment. Experiment. So operational definition, alright, is actually the definition in the lab. Okay, the definition in the experiment. Okay, so this is something I define as, alright, the definition in our experiment. So many people consistently score 0 mark when you come to operational definition. Okay, so I will show you how to improve from 0 mark to get minimum 2 mark. Okay, for me to get 2 mark in operational definition is quite simple. To get 3 mark is a little bit harder or a little bit more complicated. Okay, so for this particular video, for this particular session, I'll teach you how to get 2 mark first. Okay, then only in the next video I will show you how to get 3 marks when it comes to operational definition, which I think is a good improvement, because imagine you used to get 0, you have no mark at all, but now you get 2 mark, which is considered quite good already. Okay, so how to get 2 mark for operational definition? Actually, it's very simple. To get 2 marks, okay, this is a 2 mark answer. Okay, so to get a 2 mark for operational definition, you need to tell people 2 things only. The first thing, you must tell people what to do, what you need to do in the experiment. Okay, number 2, you must tell people what you will see. What you will see means the result. Okay, just tell people what you need to do and what you are getting, what you see or what you get. Okay, what you get as a result, that is good enough. So what you do is the simple procedure. I don't want a super lengthy procedure. Don't want. I want a short and simple procedure only. So what you get is the result. Okay, so just tell people what you need to do to get the definition you want and what is the result that you will get. Okay, I will give you 2 examples. Hopefully it can give you some rough idea. Then we go back to do the question we have just now and we finish with this particular lesson. Okay, now what if just now I go back to the same question? What is the operational definition of acid? So how we give the operational definition of acid? So ask yourself what you need to do to prove or to test it is an acid and what you will get if it is acid. Yeah, so what we need to do, guys, when we have acid, how you prove something is acid? Acid, if you want to prove it is acidic, you must dissolve it in water. You must dissolve the substance in water first if you want to know it's acid. And after you dissolve in water, how to know it's acid? You put in a blue litmus paper. You put a blue litmus paper. So if that substance is acid, what you are getting? You are getting blue litmus paper turn red. So what is operational definition of acid? You write this. When a substance, when you take a substance, you go to dissolve in water and then tested with blue litmus paper. Okay, so everything that you can see on the screen here, this is what I do and what I will get. What is the result when I when I dissolve a substance in water and test it with blue litmus paper? Alright, you will realize that the blue litmus paper turn red. Okay, the litmus paper will turn red, and that's it. So this is operational definition of acid. Okay, so you take a substance, dissolve in water, you put a blue litmus paper, the litmus paper turn red. Okay, so you must tell people what you need to do to get the definition of acid and what you will get as a result, okay, when it is acid. Okay, so I show you another one more example. I show you another one more example here. What is operational definition of Voltaic cell? Okay, we learned about Voltaic cell in your Form 4 Chapter 6. So recall back, what is Voltaic cell? So Voltaic cell, you have a voltmeter. You go to immerse 2 different metals, okay, into a solution. Okay, Voltaic cell is used to produce electricity. So what is operational definition for Voltaic cell? What we need to do to get the Voltaic cell and what we will get as a result. Okay, so what we need to do? So when 2 different metal, okay, we go to take 2 different metal and we immerse the 2 different metal in a solution. Okay, when it comes to electrolysis, we don't call it solution, we use a more specific word called electrolyte. When two different metals immerse in electrolyte, this is what we do. So if this is a voltaic cell, what you expect you will get? What is the result? Voltaic cell produce electricity. So if there is electricity, what is the result you can get? You will see the voltmeter got reading. So you will see that voltmeter, okay, show reading. Or if you don't want to say voltmeter show reading, you can say the voltmeter needle, the needle of the voltmeter deflects, also can. Yeah, so what I do, I take two different metal immersed in electrolyte, so I can produce my voltaic cell. What I will get, the voltmeter got deflection, prove to me that it produce electricity, which is what voltaic cell do. Okay, so remember, operational definition has nothing to do with the definition from textbook. Operational definition, you must tell people what you should do and what is the result you are getting. Okay, by doing these two what we call that steps, you should able to get the good operational definition. So let's try to go back to the questions that we have early on. Okay, so now let's come to here. All right, so for this question that we have, okay, that we do just now. All right, so let's try to do this. Okay, so look at question F. State one operational definition for conductivity of electricity in this experiment. So they clearly tell you this experiment. So just copy paste lah, use back the same experiment they give you. So you don't need to think and design another new experiment. No need, because they already mentioned in this experiment. So what we want, conductivity of electricity. Okay, so focus on two things. Tell people what you need to do and what you are getting. Alright, so we want to conduct electricity. So how to conduct electricity? Look back the diagram they give you. So what they do, they put carbon electrode into a molten sample. But we have three molten samples here: naphthalene, lead bromide, and glucose. How to know which one we should use? The question asks about conductivity of electricity. So we want to conduct electric. So when we want to conduct electric, we must make sure the ammeter got reading. So we use molten lead bromide. Okay, so what we do, we go to immerse carbon electrodes into molten lead to bromide. So that is what we do, okay, for to get the conductivity of electric. So what we will get, what is the result? So if we immerse the carbon electrode in molten lead bromide, if there is electric conductivity, what we expect we'll see, what we will get, we will see ammeter got reading, or you can see ammeter needle deflect. Okay, so we will see ammeter needle deflects, or we can see ammeter show reading. Okay, so that is how we going to write the operational definition. So if you can write like this, normally you will get 2 marks already. Okay, so in the next video I'll show you how to get 3 marks. For 3 marks is a bit more troublesome. 2 marks is easy, just talk about what you do and what you get. But 3 marks you must arrange in a more proper format, which I will discuss more in the next lesson. Okay, alright, so that's it. So a very quick summary here. Okay, so up to this moment we have run through quickly on this mini course. So on this mini course we have run through on how to record data, the decimal point you should use, what is inference, what is hypothesis, what is the observation, how are you going to take action to play with different variable, and most importantly, the operational definition. Okay, all right. So guys, if you learn something from this video, please like this video and share with your friends if you think this is going to help them. Okay, and leave a comment below to share with me what you learned today. Okay, leave a comment below to share with me, okay, anything you learned from this lesson. Okay, I will put a download link in the comment section, in the comment session, that you can download all the materials that I use to discuss on today paper 3 session. Okay, all right, so I'll see you in the next video.